Okay, there we go. I think we had a little bit of technical difficulty initially, but I think we're fine now. Um, Let me see. Can everyone hear me at the moment? Is everyone okay? Okay, there we go. Right. So apologies for the late start. um, Setting up the second monitor this time proved a little bit more challenging than I would have liked. Um, but we're back for another term of squads. This time it's going to be about chemistry, all GCC chemistry, so really, really exciting. Unfortunately, for whatever reason, Streamlabs isn't picking up my webcam, so I will need to have a look at that in time for next week. But hopefully, all of you can hear me just fine. I can see a few people have joined. Hi, Lyrics, good to see you again. And Lila, also nice to meet you. Hi, hope you're well this evening. Who's excited for an exciting session of GCC chemistry? Today we're going to be looking at bonding and how we can make structure and bonding really, really easy. These squads are going to be half an hour this term, just to try and get more engagement. So that's something really exciting. How am I? I'm good, Lyrics. Thank you. I hope you're well also. It's good to see you again. Hope all of you had a good Christmas and a good New Year as well. Be really, really cool to see what all of you got for Christmas. Hopefully, Santa, if you still believe in him, was good to you this year. Um, but yes, we're just going to get started really shortly with some structure and bonding in GCC chemistry because I know for a lot of you, chemistry is a really challenging subject. A quick thumbs up in the chat who finds chemistry difficult and who is excited to go over some structure and bonding today. We've got a good few topics lined up for the next 10 episodes as well. So definitely it's going to be a really, really useful series for all of you. So yes, I'm certainly excited. Maya, good to see you. Thumbs up from you. Okay, great. And Kira, it is difficult sometimes. I'm glad you agree. It's great to see all of you this evening. And Jaff as well. Good to see you as well. Um, and the expert is back. Hello again. Good to see you this term for another chemistry squad this time. Really, really excited if you couldn't tell by my tone of voice. Um, but what we'll do is we'll get right into the chemistry and then we'll spend an extra 5-10 minutes or so at the end. If anyone has any questions, general chemistry questions or anything else, or just a quick conversation, then by all means, I'll hang about for 5-10 minutes or so. So let's get right into structure and bonding now. And I've got a graphics tablet, so it's going to be really interesting in that I'm going to be drawing lots in the lesson space today. So when we think a little bit about structure and bonding, the first thing we need to sort of remember is why things or why elements bond in the first place. Why do they react? Well, what we need to remember is that generally in chemistry, elements react with each other because they want to become more stable. Okay, so we're going to type that out actually. We're going to type that out there in the lesson space. So we're going to say that elements react in order to become more stable. Now, what are the most stable elements in the periodic table? Which group are the most stable? Pop something in the chat. I want to see some answers. I want to see some engagement. Which group in the periodic table is the most stable? So we're going to type that out. Elements react because they want to achieve stability. Okay, I'm seeing loads of answers flooding the chat. This is brilliant. So I've got Sankavi said 0. Kira, you said the noble gases. Elena, you said group 0. Lyrics, you said 8/0. And the expert has also said 0. Fantastic, guys. Really proud of all of you. You're right. Group 8 or group 0, all the noble gases, they are all the most stable in the periodic table. Okay? And the reason that they're the most stable is because they all have a full outer shell of electrons. Let's take helium, for example. So we're going to draw helium. Disclaimer, I did not take GCSE art, so you can tell from my diagrams they're slightly poor, but hopefully you can understand what the drawings mean. So we know that helium, as per the periodic table, has 2 electrons in it. And we know that the first shell can hold up to 2 electrons. So by drawing that, you can see that helium already has a full outer shell of electrons. Okay, and that full outer shell means that helium has no desire whatsoever to react with anything. Okay, so that is helium. Okay, we can apply the same type of thought process to neon. So neon's the next one in the noble gases, and that also has a full outer shell. Now, we're not going to draw the innermost shell, we're going to draw the outermost shell, and the outermost shell has 8 electrons. Okay, so we're going to draw that out. 1, 2, 3, 4, 5, 6. See my electrons merging into one. I'm glad I had that disclaimer that I'm not great at art. 8. So we've got a full outer shell there. So between helium and neon and all the other noble gases, what you'll find is that none of them have a desire to react. They are all what we call inert. Okay, so all the noble gases are inert, and it's a really fancy way of saying they don't react with anything. And that's why the noble gases are good in neon lights, for instance. It's why they're useful in balloons, because they're not going to react with anything. If we then put that into perspective, though, it then means that everything else in the periodic table will have a desire to react, because of the simple reason that they don't have a full outer shell. Now, for bonus points, I want all of you in the chat just to type what types of bonding you're aware of. There are 3 types that I can think of that we're going to try and whiz through in the last sort of 15 minutes or so, 15, 20 minutes. So, what are the types of bonding you guys already know? So I can see Sankabi, you said covalent, very good. Ajaf, you said ionic. Wow, loads of responses in the chat, guys. Really proud of all of you. Robert, you said ionic, covalent, and metallic. This is absolutely fantastic. Really proud of all of you guys. If my webcam was working, I'd show my little golden trophy that I showed last term. But just give yourselves a pat on the back. Imagine that you're holding a golden trophy because all those answers are correct. Absolutely brilliant. This is why this chemistry squad is 10 out of 10. So, you're all right. There are 3 types of bonding. You have ionic, you have covalent, and you have metallic as well. Now, what we're going to do is we're going to do a little bit of drawing, a little bit of talking about the different types of bonding. Now, does anyone have a type of bonding that we should start with? First answer determines. So the first person to say a type of bonding is the one we'll start with. Let's see who's first. Ionic. Sankabi, you're first. Ionic. So we're going to go with ionic bonding first. Okay. Kira, you were second. So after ionic, we'll go with metallic, and then we'll go with covalent last. Now, if we start with ionic bonding, we know that ionic bonding happens between a metal and a non-metal. So we're going to write that out. Ionic bonding happens between a metal and a non-metal. Okay. Now, I'm going to take the most classic example that you can think of, and that's going to be sodium and chlorine. So sodium and chlorine, they're going to react. What group of the periodic table is sodium in? Does anyone know? Put it in the chat if you do know. 1. Okay, brilliant. Brilliant. You guys are on fire this evening. Absolutely proud of you. Well done. So sodium is in group 1 of the periodic table. So we're going to write that out. And we're just going to draw a nice ring around it, like so. And then, what about chlorine? What group is chlorine in the periodic table? 7. Fantastic. You guys are absolutely smashing it. Now, because all of you guys are brainiacs, I'm sure you'll already remember that there's a relationship between the group number that an element is in and the number of electrons that are in the outermost shell. So because sodium is in group 1 of the periodic table, what that means is that it has 1 electron in its outermost shell. Similarly, because chlorine's in group 7 in the periodic table, it has 7 electrons in its outermost shell. Now, quick thumbs up if you knew that, thumbs down if you didn't know that. And if you put thumbs up, fantastic, that's a bit of revision. And if you didn't know that, well, that's still great, because now you do know it. And so by the end of the lesson, you can give a thumbs up. Okay? So we've drawn that out there. Okay, we have 1 electron in the outermost shell of sodium. We have 7 electrons in the outermost shell of chlorine. Now, when these two react, we need to ask ourselves, well, what's going to happen next? Well, we know that when a metal reacts with a non-metal, as is the case with ionic bonding, they're going to give and take electrons, aren't they? So, which do you think will give away electrons? And what do you think will take the electrons? What do all of you think? Pop it in the chat. Okay, so Ariba, you said sodium. Robert, you've also said sodium. Sankavi, you said that sodium gives away. And Ariba, you said that chlorine gains. FB, you've said metal gives away, which is sodium. Kira, you said the same thing. Well done, guys. Proud of every single one of you. That's absolutely brilliant. So sodium's going to give away that 1 electron. And chlorine's going to gain that 1 electron. And in doing so, both of them achieve a full, stable outer shell. So what we then do in GCSE chemistry is we draw that out like so. We put a nice little box around it like so. We write our symbol in there. And then we put a positive up there. Now the reason we put a positive there is because sodium has lost 1 electron. Now remember that electrons have a charge of -1 each. So now sodium has become positive by 1, hasn't it? Because it's lost 1 lot of negative charge. So in terms of the proton to electron ratio, it's got 1 more proton than electron. So therefore it's going to be +1 charge. And we're going to apply the same thing to chlorine. Now with chlorine, what we're going to do is we are going to draw all the electrons like so, but to show that one of those electrons came from sodium, actually no, I think I made a mistake here. That should have been a dot actually, so we're going to just make that a dot instead, like so. You've now got a dot cross diagram like that, and now you can kind of see that it's taken 1 electron away from sodium. Okay, and now this has a charge of -1. Okay, now when these two come together, you then have what is called an ionic compound. Has that made sense for everyone so far? Thumbs up in the chat if it makes sense. Hopefully it does. All of you have been absolutely brilliant this evening, so I've got no doubt that you're absolutely smashing it, that you've understood everything 100%. Fantastic. I'm seeing lots of yeses, lots of thumbs up. This makes me very happy. Well done, guys. Super proud of you. Now, when we look at these, then when we look at sodium and chlorine, we see them come together. We then have what's called an ionic compound, okay, or an ionic bond. We'll start with an ionic bond. In chemistry, and this is a nice little trick for you, a nice little exam hack, if you will. Examiners really like it when you describe ionic bonds as electrostatic forces of attraction between oppositely charged ions. I'm going to actually make that text a bit smaller so everyone can read it a bit better. There we go. Okay, so that is the key way to really describe ionic bonds. They are this electrostatic force of attraction that exists between oppositely charged ions. I don't know why an arrow is popped up there, but it has. So we're just going to get rid of that. So that is what ionic bonds are, electrostatic forces of attraction that exist between oppositely charged ions. Now we can use that type of thought process to then try and explain some of the properties that you see with ionic bonds. So I want everyone in the chat, firstly, to give me a property of an ionic compound, but in your answer, you must also include an explanation as to why it has that property. So that's also important. I don't want you just to list the property. I also want you to tell me why it has that property. That's just as important, if not more so. In an exam situation, examiners want to see what you know, but they also want to see that you understand the content. So I want you to tell me what a property is of an ionic compound, and I want you to tell me why the property exists. So let's have a look here. So, okay, so Robert, you said it's an electrical conductor as it has electrostatic forces. Okay, so I'm going to park that one to one side because actually you're half correct there, actually. So let's address that one first. We'll address it one at a time. Ionic compounds are conductors only when in solution or molten. Okay, now I know a lot of you probably do physics as well. And remember that in order to conduct electricity, you need free charged particles, don't we? Now, in an ionic compound, generally what you have is you have all the ions and they're all held together, aren't they? If they're all held together and they're all fixed in place, they're not free to move around. So they can't really carry a current anywhere. They can't conduct that charge. But if you were to melt an ionic compound and overcome these strong electrostatic forces of attraction, or you were to put it in solution where the ions aren't held together anymore, they can then carry a current and therefore conduct electricity. So Robert, you are correct, but just with a little bit more detail there, mate. It's all about them being either molten or in solution. Ionic compounds as a solid can't conduct electricity, but in solution or in molten states they can, because the ions are free to move around and therefore carry a charge because those ionic bonds aren't holding them in place. Hopefully that makes sense. Everyone put a thumbs up if that made sense. We're now going to go on to the other contributions that some of you have brilliantly put in the chat. I'm going to have a quick read through them. They all seem to be about high melting points and boiling points, so we're going to look at that. Fantastic. So you're correct. Ionic compounds have high melting points and boiling points because they have strong electrostatic forces of attraction. The only way that that answer that you've all given could have been like a 10 out of 10 rather than like a 9 out of 10 is just mentioning that therefore it requires a lot of energy to break. And actually, I think, Kira, you mentioned that, so well done there. It's just about mentioning that a lot of energy is required to break it. So it's just bringing your answer back to the question, but otherwise that's absolutely fantastic. Does anyone else have any other observations about ionic compounds? Anything else? We have high melting points. We have talked about electrostatic forces of attraction. We talked about conducting electricity. Anything else? Even if you haven't got an explanation, just tell me anything about ionic compounds. Anything else at all? So, Will, you said that they're brittle. Yeah, I suppose so. Brittle in the sense that if you were to hit it and the layers slid, then it would break. So, yeah, I guess they are hard. They're therefore brittle. They're not malleable. Definitely, they're definitely not malleable. We'd say that metals are malleable. Sankavi, you've asked, do they dissolve easily? Generally, yes. Ionic compounds do dissolve very well in water in an aqueous solution. So that is correct, yes. Now let's see some other questions we've got here. So QE, hopefully I've said that correctly. What is the difference between electrostatic forces of attraction and intermolecular forces? Now, this is a good question. They are one and the same. So intermolecular force is an umbrella term. Okay, it exists between molecules. Okay, an intermolecular force could refer to the types of attractive forces you have between covalent molecules, like let's say water or alkanes or alkenes. But then ionic bonds are also a type of intermolecular force. The key is the word intermolecular, because inter means between. Okay, one of the things that we often get wrong is we confuse intermolecular forces with covalent bonds, and they're different things. You do have intermolecular forces in covalent bonding, so covalent molecules have intermolecular forces, and we generally reserve the use of intermolecular forces with covalent molecules, but ionic bonds are a type of intermolecular force. Okay, hopefully that answers your question. So Panema, you have said when they are dissolved in water, they dissociate into ions. Yes, they do. Will, you've asked why are they soluble in water? Well, water is very interesting in the sense that the molecule itself has a partial charge. This kind of dips into a bit of A-level territory, but part of water is negative, part of water is positive, and so it can kind of fit around the ions really well. So there's a bit of charged activity happening in water and with ions, and that makes them go together quite well. And also, I can see that you've also answered Elena's question, so well done. Okay, so MK, you have asked what about metallic bonding, and we said that we were going to go into metallic bonding next. I think everyone's quite happy with ionic bonding. Now I'm going to move the page to the right. We started a bit late, so we might go over a little bit, and I don't want to just sort of leave without answering all of your wonderful questions. So let's talk about metallic bonding. Now, metallic bonding exists within a metal. So let's say, for instance, we have something like, someone give me an example of a metal, any metal. First metal that crops up, I will use as my example. The first metal everyone can think of. Okay, sodium, or even copper. Or potassium, aluminium. We got loads of examples of that. I'm really loving the enthusiasm and the engagement. Fantastic, guys. I think we've used sodium with ionic bonding, so let's go with copper instead. Let's go with copper. So I'm just going to draw out copper. Now, within a metal, what we have are metal ions, and these metal ions are arranged in layers. Okay, like I said before, not the best with drawing, didn't do art GCSE for a reason, but hopefully you can see that these are all metal ions and they're all arranged in layers. Okay, now what you've also got, I'll do some different color. Let's use orange. Why not? Let's use orange. And I then have electrons, what we call delocalized electrons, and they are throughout the structure, like so. Not the best diagram, I appreciate. I'm using a slightly different whiteboard today, so it's oh, you know what? I figured it out. There we go. Let's just get rid of that. Ah, there we go. Cool. So these are the negative charges. These are the electrons. So these ions are arranged in layers, and you have these delocalized electrons throughout the structure. Okay, and I'm going to draw little positive charges so we know that they're metal ions. Now, the key thing to remember here is that you have electrostatic forces of attraction. Okay, and these electrostatic forces of attraction exist between the delocalized electrons and the metal ions. Okay, so that's what we have going on here. You have delocalized electrons, and you have electrostatic forces of attraction between the metal ions and the delocalized electrons. Now, I can see a couple of questions. I'm going to answer these questions first, and then we're going to dip back into metallic bonding, and then we're going to do the same thing that we did with ionic bonding, where I'm going to ask all of you about some of the properties. So Kira, you've asked, do the layers of a metal slide over each other, or is that only in graphene? You are correct. Metal layers do slide over each other, and it's for that reason that it explains one of the properties of metals, which I will ask you about shortly. But they do slide over each other, similar to graphene. And MK, you've asked, why does hydrogen have a +1 charge, but it's a gas, it's a non-metal? So, I think this question, it depends on your circumstances. So, in some bonding, hydrogen behaves more like an ion, in some covalent, okay? You may be referring to acid-base theory, where we generally say that in an acid, it dissociates into hydrogen ions and, let's say, if a sulfuric acid, sulfate ions. Okay, so slightly different type of bonding there. In that instance, it's more ionic in nature rather than covalent. Okay, does that answer your question? So Brioni, you've asked, about the electrostatic forces of attraction. So the electrostatic forces of attraction exist between the delocalized electrons and the metal ions. Hopefully that answers your question. So let's think about properties then. Just like you all brilliantly did with ionic bonding, I want all of you to tell me what are the properties of metals, and I want you to explain why that's the case using their metallic bonding. If that question made sense. Actually, saying that back, I don't think that sounded great. Let me rephrase. Like you did with ionic bonding, I want you to give me some of the properties of metals and then use the bonding that you have in metals to explain those properties. I'm also loving the fact that you guys are helping each other in terms of answering questions in the chat. Absolutely brilliant, spot on. So let's see what we've got here. Kira and Indavir, you've both said that they conduct electricity because they have delocalized electrons to carry the charge. Spot on, well done. That's exactly it. Metals can conduct electricity when solid because they have delocalized electrons that are free to carry the charge. That's in stark contrast to when ionic compounds are solid, because when they are solid, okay, they can't conduct electricity because there are no delocalized electrons. There are no free charge particles. There are only ions. Okay. Now, FB, you've said that metals are soft because they have layers that the atoms can slide over each other. So the second half of your explanation is good, and I think that refers to what Fatima has said about malleability. Now, metals generally aren't soft, depending on the metal. The group 1 metals are soft, for instance. But metals are quite hard, and their ability, or the iron's ability to slide over each other, relates more to their malleability. So when we say malleable, we mean we can just sort of bend it into shape, right? And that's why, for instance, cars are useful and cars look the way that they do, because you can take a sheet of metal and you can sort of bend it into whatever shape you want it to. Okay, and that's because the ions can slide over each other. The layers can slide over each other very, very easily because none of them are really fixed into place. Okay, so well done. We've got malleability we talked about, and it's because the layers can slide over each other. We talked about the fact that metals can conduct electricity. What else have we got here? So MK, you said that sonorous are malleable as they have delocalized electrons. So yeah, they're malleable because the layers can slide over each other. And I suppose you do have the electrostatic forces between the ions and the electrons, so well done. Sophie, you said metallic bonds are very strong and most metals have high melting points and they're good structural materials. Yes, very good. Their high melting points and boiling points make them very sturdy, and therefore that is why they make great building materials. Will, you've asked a good question. How are malleability and ductility different? And I was waiting for someone to ask this. Malleability is about bending something into shape, but ductility is strictly about almost pulling metal into long, thin pieces of wire. But the explanation for both of those properties is exactly the same. Both of them are dependent, and I suppose contingent, on the ability for metal ions to slide over each other in their layers. I hope that answers your question, Will. So the properties are different in their definition, but the explanation is exactly the same. Both of them are dependent on layers being able to slide over each other. Fantastic. Okay. So we're doing really, really well. I know we've gone over with time. I am sorry, that is my fault because of technical difficulties, but next week we'll get it right. We'll get it on time. But I'm really proud of all of you for staying on. It's been absolutely brilliant so far. We have gotten up to the half an hour mark, so I don't know whether we'll have time to go over covalent bonding. But I did say I'd stick around maybe 5 more minutes or so. So if anyone does have sorry, if anyone does have any questions about covalent bonding or about anything else with chemistry, then I'm more than happy to answer questions. Ajaf, you have said, if you do combined science at Excel, can you give any tips for recall and revision? So, one website that I always plug, not because I have any affiliation with them, I don't. Physics and Maths Tutor, I think is absolutely brilliant. It is a great website that breaks things down into your specification. You can do questions for individual topics. In terms of revise and recall, I would say, maybe making flashcards. Everyone's slightly different, so I use flashcards loads at GCSE, and I liked using loads and loads of colours. Sometimes what I would do is I would record myself explaining something and listen to it back, and then have someone ask me questions and then try and say them back. So to that, I would say it depends on how you learn. And interestingly enough, you can go on the My Tutor YouTube channel, and I actually have a series on study skills about learning about your learning style, which you can check out. If you work well with talking, then maybe talking to friends, studying with friends might help. If you're more visual, then maybe flashcards. But hopefully that answers your question. Kira, you have asked if I can explain electrolysis. I'll try to super quickly. Electrolysis is essentially where we take an electric current and use it to split apart an ionic compound into its individual components. This is generally reserved for metal compounds that are quite high up in the reactivity series, where you can't use carbon to extract it, like you can use carbon with iron, for instance. So you can take something like aluminium oxide, you would melt it down into its electrolyte, and you would then run a current through it. You have two electrodes. You have one electrode on the left, one on the right. One of them is your cathode, one of them is your anode. So your positive ions will go towards the cathode. At the cathode, your positive ions will gain electrons, so you have reduction happening there, and then you have your nice sort of separated metal there. And then at the other electrode, you have your non-metal formed. Now, in the case of something like aluminium oxide, where you have oxygen, you tend to have, sometimes you'll have like a carbon electrode, which might erode away over time because oxygen will react with the carbon to form carbon dioxide. But that is what electrolysis is in a very short 2 to 3 minute explanation. Hopefully that makes more sense. If it doesn't, then by all means, there are loads of great videos on YouTube you can check out. There are, I mentioned Physics and Maths Tutor as well. You can check that website out too. I think I have a session on electrolysis. I need to double check. But I will get back to you on that one. But tune in next week. I don't think it's next week that I'm doing that session, but at some point I might be. But if there's demand for electrolysis, I'll see if I can rework some of the titles and get back to you. So MK, you have asked if we can do earth resources next, and potable water and phytomining and bioleaching. I don't actually, that's not one of the ones that I actually had scheduled for. Let me see what I've got, because I've actually been organised and I have put together all the titles. Next week we've got balancing equations. Now, would people rather I went over balancing equations, or would earth resources be more useful? Elena, I do have a session on like reversible reactions and the Chatelier's principle, which I'm going to try and work the Haber process in there as well, because that's definitely the key point about reversible reactions. But it could very well be that MK we might not have. Let me see. So we've got half on balancing equations, and so far half. Okay, so a bit of both. Okay, I'll tell you what. Contingent on me getting here on time, which I will do next week, we will go over half and half. So we'll go over balancing equations for the first half, and then we'll go over a bit of earth resources and sort of potable water next week. So in the second lesson. So that's what we'll do. Does that sound like a plan? Alternatively, there is a session I have towards the end, which is about groups in the periodic table, which I could replace with Earth resources instead. That is like group 0, 1, and 7. So if people don't really want to go over those groups, then we could go over Earth resources then. Let me know what you think. Does that sound like a plan instead? Maybe have a whole lesson just for balancing equations, maybe a whole lesson on Earth resources, but then the Earth resources one is done instead of groups in the periodic table. So instead of 0, 1, and 7. What does everyone think? If not, then we'll try and do a split 50-50 down the middle next week. So Ajaf, you've said that's fine. That's great. We'll see what some others say, and if so, then we'll then move 0, 1, and 7 out, and then bring Earth resources in. Elena, you've asked, is this also higher tier triple science chemistry? So what I've tried to do is I've tried to put together the lessons in such a way that it caters to all the exam boards. So whether you're doing AQA, LXL, CIE, so the way that I'm going over it isn't specific to an exam board, but it's just general chemistry across GCSE. Hopefully that answered your question. FB, yes, the next chemistry squad is going to be next Wednesday at the same time. So do tune in and tell your friends if anyone else is interested in learning a good bit of chemistry. Did everyone have fun this evening? That is the main thing. Did everyone find it useful? Did everyone learn anything? Hopefully you all have. Hopefully you've enjoyed yourself. And hopefully you've learned something. So Kira, you've asked, do I set homework? Well, not particularly. I do tutor one-on-one, but I wouldn't necessarily set homework for these sessions. But if you would like to do questions, then sure, by all means, you can do some part-time questions in your own time. And if you want to bring them to the session next week, then by all means, we'll make time at the beginning, maybe go over some of those questions, and then, yeah. So if you want to do that, then yeah, we can implement that. We can certainly implement that. MK, you've asked, are these on every week until GCSE exams? Well, we've got 10 sessions. So that's what, 2 months. Your exams are in May, so these probably finish before then. But I'm sure if my tutor, there's a demand for these squads, then maybe, yeah, we can continue them until exams. But we'll see, is the short answer. We will see is the short answer. That would be a discussion between me and my tutor, but yeah, we'll see all the same. All right, fantastic. Honestly, it's been absolutely brilliant teaching all of you this evening. I'm aware that I have gone over time nearly by double the time. But no, it's been brilliant, so thank you. I think I'll let it lapse for another 3 minutes, and then we'll say good evening for now. And then you can all tune in next Wednesday at the same time, 5 to 5:30, and we're going to be going over balancing equations. And then, as we said, we'll be balancing equations next week, and then the following, and then towards the end of the study squad series, well, the chemistry squad series, I should say now, we'll then go over Earth resources. So Earth resources will now be number 9, and then balancing equations number 2. Lyrics, you've asked, can I do a session on energy stores and systems? I think that's like exothermic and endothermic reactions. I do have a session on that. That one is number 4. So number 3 is going to be all about moles calculations, because I know those pesky moles calculations are always a bit of a hassle. Number 4 is going to be on exothermic and endothermic reactions, so that's energy stores and systems. And number 5 is going to be about rates of reaction, so we're doing a bit of a whistle-stop tour and everything. The expert, is study squad still on, NK? So it's, I'm not too sure whether it is. I'm not doing the study squads. I don't think we are doing them. I mean, if there is demand for study squads as well as chemistry squads, then I guess that would be another discussion with my tutor to see how we would get that in. As a curiosity, if we were to do study squads, would anyone be keen for them to happen on a weekend? Do weekends work for people? I don't ever really know. We've been doing weekdays, but I don't know whether like a Sunday afternoon would work for people if we did study squads. It'd be interesting to see. If there's demand for it, then maybe I could talk to my tutor and we could see how that would work. A lot of yeses in the chat. That is really exciting. So yeah, I'll let my tutor know, and if there is scope to have a study squad happening at the same time, then sure, we'll arrange for a weekend slot or something. MK, you've asked where can you view the lesson titles for the 10 weeks? So the lesson titles are all internal. I will. Let me think. Can I post them in the comments? I'll have to check with my tutor and get back to you because it's all internal at the moment. We sort of, release them each week just to keep the suspense going. Ajaf, you've asked, do I know any websites for combined science, specifically most of the triple content? So combined science, I know that's AQA, isn't it? I think that Physics has questions on combined science. I think you go under science rather than chemistry or biology. Save My Exams also has a few bits there, although I think they've got a paywall. I've never used the paywall at all. So I couldn't tell you whether it's worth the investment or not, but I don't think it's too expensive. That would be my recommendation there. I don't actually know whether there are any more squads for science, like biology and physics. I'm not too sure. Inga, could you confirm, do we have biology and physics squads? We might not, but again, squads it's a developing thing. So last term, as you know, we only had 3 squads. We had one math, study skills, and coding. Now we have math, we've got chemistry, and we've got coding. And I'm sure there'll be more as we go on. So watch this space is the short answer. It's going to be really, really exciting, and I'm really glad that my tutor's gotten this. Well, we've always been digital, but I'm glad that we've reached out to this sort of domain of live streaming. It's really cool. It's really fun. What else have we got here? What typical 5-6 marker questions are on structure and bonding in the chemistry GCSE? I generally see things about either ionic compounds, so explaining the properties, and if not that, then it's generally about things like diamond and graphite, so comparing the two. So what is the bonding like in diamond and graphite, and what are the properties? And an explanation of those properties, sort of like a compare and contrast. Those are the ones I tend to see in exams. Questions about metallic bonding, you do see 5 markers occasionally, but I tend to see 4 markers with those. I would say that with structure and bonding, there is the scope for them to ask you sort of compare and contrast to be really, really confident on your knowledge on this. Does my tutor do English? Yes, there are English tutors on my tutor. They're absolutely brilliant. We may have English squads in the future. Like Inga has just said, there will be more as we go on. We've got loads of exciting things lined up, so do watch this space. And hopefully, with every single term, you'll have me doing one of the squads or 2 of the squads. We'll see how things go. But how is everyone this evening? Hopefully everyone's had a good day. I'm glad that everyone has enjoyed this session. Honestly, it warms my heart, and it makes me that much more passionate about chemistry. Now, I'm not too sure whether or not the webcam will work. Hopefully, it will work next time. If not, then I'll create like some kind of little avatar or something to go up there instead in my likeness, so it's not just a random green space. MK, are there A-level sessions like this? We don't have an A-level chemistry squad, but that is not to say that we won't have one in the future. At the moment, we're just doing GCSE for this run, but it could be that next time we have a GCSE and an A level one happening simultaneously. Again, this is our second round of squads, so watch this space. Obviously, we'll always take your feedback and we will implement it so that you guys as students feel supported. The expert, you've just answered my question anyway, but yes, I do one-to-one tuition as well. There is a link in the description which you can click on and check out. So yes, you can also check that out too. Okay, fantastic. Okay, you know it's really funny. We've essentially been doing this squad for nearly an hour now, and it's actually only supposed to be in for half an hour. I'm so sorry to the mod who's still watching the chat because I've gone over that much. So I think I will wrap it up here for this evening. Everyone, thank you so much for joining this evening. It's been absolutely brilliant having all of you here. I will see you all next week. And in next week's session, it's going to be all about balancing equations. So by the end of the session, you should be balancing equations like an absolute boss. Again, do make sure to click on the feedback link. There is a link for you to give some feedback. It's a really quick form, takes no time at all. Please fill it in because it's useful for me, it's useful for the team at my tutor. It means that we can continue to put together really fun and engaging resources like this for you to help you succeed in your studies, whether you're at GCSE, whether you're at A-level. That's what that feedback does. It really helps us. And it just lets us know what you want. If you want background music, we can implement background music. If you want more of these sessions, then we can give you more of these sessions. But unless you tell us, we don't know. So please make sure to fill out that feedback form. Inga has kindly put a link in the chat, so do check that out there as well. You can click on that link, or you can click on the link in the description. Also, make sure to check out the other squads that happen as well in the week. So we have Fliss doing coding, and we also have a new squad tutor, Sarah, who did maths on Monday, which I hear was a fantastic success. Everyone at my tutor is incredibly talented, and I'm glad that I have the opportunity to work with such brilliant tutors, such brilliant individuals. But do make sure that you check out that feedback form before you leave this evening, okay? Once again, I've been NK, or Professor NK, however you want to refer to me, for those of you who know me from the previous study skill squad from last term. It's been absolutely brilliant having all of you here. I hope you all have a wonderful evening. And remember that this chemistry squad is the best. We are absolutely fantastic. The engagement that we had this evening was absolutely brilliant. And I look forward to seeing more of that in subsequent sessions. And Inga has also, we have artificial intelligence sessions every Tuesday. That's really cool. So do check that out. That's really cool, actually. I might check that out myself. That's actually really cool. I'll probably join that, actually. That is quite cool. Right. So I think we're going to wrap it up for today. Everyone, stay safe because the weather is pretty naff at the moment. Have a lovely evening. Keep smashing chemistry. And I will see you all next week. Same time, Wednesday, 5 to 5:30. Take it easy, and I'll talk to you then. Okay, bye-bye, everyone. Have a lovely evening.